Still in day 3 notes, we're going to talk about the protractor postulate. So here, I'm just going to look at this and read it. So let me zoom in a little bit. So since this angle is obtuse, I know that I'm not going to look at the smaller numbers up here. I'm going to look at the bigger numbers because it has to be greater than 90. Okay? And obviously, looking at from this point straight up, that would be 90. Okay? And we're past 90. So it went 120, and then halfway between 120 and 130 is where it stops. So that would be 125 degrees. So now down here, we're going to be using this picture and filling in the table. So for angle LKN, so here's LKN, we're looking again at that obtuse angle, so we're looking at the bigger numbers instead of the smaller numbers. So that would be 145 since it's halfway between 140 and 150. Which means it is obtuse. For angle JKN, here we have that flat line, the flat ray, and it goes straight up to 90. So that is a right angle. For angle HKM, we have bigger than 90, so we have to go with the bigger numbers, and that falls between 140 and 150. So that would be halfway, 145. And then lastly, we have LKH. So we're looking at this very small angle here. It would be less than 90. So we're going to look at the smaller numbers. And it lands between 30 and 40, and about halfway. So I'm going to go with 35 degrees. And this would be acute. Okay, now, for example 5, the first thing I would do is I would expand my ray here. So I would place my protractor so that corner right here is where the vertex is, and you want to line up your line with the ray. So I have it lined up pretty well, looks like. And I am seeing that this I keep moving it. Has to be less than 90, so it's going to be the smaller numbers. And it shows to me like, okay, it's between 50 and 60, but it's really close to 60. If I look straight up, that's the 60 mark. So it's about 59, 58. So I'm going to go with 59 degrees. Okay. Honestly, on these, if you don't have it exactly on that corner and this lined up perfectly, you'll be off a little bit. So what I do is I just give you a few points, give or take 5 degrees. Okay. So here I'm going to expand this ray. And then I am going to match it up with the middle. So right here at the vertex, match it up. Okay. And then this goes out, and we see it's going to be bigger than 90, right? So we're between 130 and 140. This represents 140. That would be 135. So it's 36, 37. So it looks like we're about 137. Okay, so 137. Again, you could have 135, 136. As long as you are right there in that same range, you're fine. And then lastly, we have the angle addition postulate. So for the angle addition postulate, if D is the interior of angle ABC, then angle ABD plus DBC equals angle ABC. So this angle plus this angle equals the whole entire angle. Okay. So for example 6, you have to use this picture for A and B. So we're just going to use it, erase it, and then use it again. So if angle ABD was 48, and the measure of DBC was 78, how would you get the measure of ABC? Well, you would add those two together. So if I add them together, we get 126 degrees. Okay, now for angle B, for problem B, angle DBC is 74. And the measure of angle ABC is 119, so the whole entire thing is 119. Can you find the measure of angle ABD? So we would do 119 minus the 74, and that would give us a total of 45 degrees. Okay, for angle 2, if we have the measure of angle RQT is 155. So the entire angle is 155 degrees. Can you find X, and can you find the measure of the other two angles? So first, I know that if I add these two angles together, I would equal 155. So I'm going to set up that equation. And then 4x plus 3x is 7x, minus 20 plus 14, and that would be 6, negative 6, equals, oh, what am I doing? 155. I'm sorry about that, since we're talking about the whole angle. Alright, now I'm going to add 6 over and get 161. We divide by 7 and we get 23. Now for angle RQS, right here, RQS, this one, I'm going to do 4 times 23 minus 20. And let's see, that's 4 times 23 is 92, minus 20 is 72. Okay, and then angle TQS. So we can go 2 ways of finding this. We could say, well, the whole angle there, both angles together, is 155. Minus this 72. We know when we plugged in, we got 72. So 155 minus 72 is 83 degrees. Okay, also, you might want to just double check. So 3 times 23 plus 14. So 3 times 23 is 69, plus 14 is 83. So we know that either way we did it, it checked out to be the same. Okay, last one. Okay, so first of all, let's label. So DEF, so the whole entire thing is the 7x plus 4. DEG is 5x plus 1. and GEF, the little one here, is 23. Can you find each measure? So can you find X? Can you find all the angle measurements? So I'm going to say the two small angles add together equal the 7x plus 4, which is the two angles together. Simplify like terms here. And then I solve by subtracting 5. So I would get 2x plus 4. Subtract 4, I get 20. And x is 10. Now, if I have to find DEF, I'm plugging 10 into the 7x plus 4, which is 74 degrees. Okay, to find DEG, a couple things. You could either, one, take 74, okay, we just found that as the whole angle, minus this little piece, 23, and get 51. But if you want to check yourself, you could also plug the 10 into 5 times x plus 1. So 50 plus 1 is indeed 51 degrees. So it does work out, and you do get 51 degrees both ways you do it.